Okay guys, in this video lesson we're going to start talking about current and how we get current to flow inside our circuit. Alright, so first of all, for us to have current or the movement of electrons through a circuit, we need to have an uneven distribution of charge. Okay, so think of like a battery, right? So we plug a battery into something and that battery has power for us, we know that, but really what that battery has is an uneven distribution of charge. So on one side of the battery, if you take a look at this battery down here, we have an excess of electrons, or excess of charge, we should say, in it. Okay. The other side, we have the absence of it. So you hook it up to a circuit, and the electrons are going to flow through that circuit in a way to get back to that positive side of the battery. Okay. Now, that flow of electrons is called current. That's what we got. All right. Now, keep in mind that the electrons do flow from negative to positive, which is the opposite of the electric field, which would actually go from positive to negative. Okay. And then, of course, this uninterrupted loop that we have here is called our circuit. All right. Now, with current, we can start relating current back to other terms that we've been using in this unit. So to do that, we want to go back to that idea of what's our model for this? What's a way to help us visualize that? And we use the waterfall for electric potential. So for current, what we want to use is this idea of a river. Okay. And when it comes to like rivers, if I said how much water is passing by this point in the river in a given amount of time, you would say, oh, that's just the flow of the river, right? That's how that river is flowing. Well, that's what current is too. So how much water passes a given point is very much like how many electrons pass a given point within that circuit, or what that flow is. So this idea of a wide or fast-moving river would be like a high current type of scenario, and a narrow or slow river, okay, would be something like low current. Another way to visualize it is if you have two containers, both equally high up in the air, emptying out through a pipe. Okay, they have the same height, so their electric potential will be the same, so we don't have any differences in voltage here. However, in this case, because this pipe is bigger, it allows for more water to flow through it per unit of time, so it would have more current. This one is narrower, so it would have less current, as you take a look at those two things. All right. We can actually calculate current also, just like we can calculate voltage. All right. So our electric current is that movement of charge per unit of time. Okay. So instead of saying like water per time, it's current or charge per time in here. Okay. So it's a rate. It's a speed essentially is what we're really talking about here. Now the symbol we use for current isn't C, because C represents that coulombs of charge. So we used an I, and that I stands for current intensity, or the intensity of that current, or how much flow is actually going on there. Okay, we measure current in the amperes. Very often we shorten this down just to say amps, but the full word is amperes here, which is a capital A. And if we take a look at our equation, our current is really our change in charge over our change in time. Okay, or it's a coulomb per second. All right, because coulomb is our measurement of charge and time is our measurement, or sorry, seconds is our measurement of time. Okay, so it's our coulombs per second is what we're measuring here. Now, a typical household current or a typical household circuit, okay, things you plug in your lamps into, your cell phone chargers into, they can carry up to 15 amps of current, okay? So if they can handle 15 amps of current, how many coulombs of charge does that outlet handle every minute? All right, so let's take a look at this idea. Well, it holds up to 15 amps of current, so that's our I, that'd be our 15, and we want to go every minute, which would be 60 seconds. So it'd be 15 here. Our time is 60 seconds. So if we rearrange this, solving for the charge that we have, we would say that the charge that's available is your current times your time, which is your 15 amps of current, times 60 seconds, or we get 900 coulombs of charge. Or basically what we're saying is that we get 900 coulombs every minute that could pass through that circuit. Okay? Now, there are two different types of currents, but in our next video lesson, we will talk about that. Thank you.